Hello, everyone. I'm Susan Nash, AAPG, and I'm thrilled to be here. This is our series Pivoting 2021. And our focus in this series is on opportunities and also just for basically thriving with change. Because one thing that we are seeing in 2021 is a lot of change, which means a lot of opportunities and a lot of opportunities for knowledge sharing. I'd like to talk a little bit about our format tonight. So our goal tonight is to talk about new technology, adoption, practice, and strategy in 2021. So what we have tonight are, we have a wonderful group of people who are going to talk about how they are helping get technology adopted into applications in the field, or if they're in a company, how they make those decisions. And so we'll have just brief presentations from our panelists, but what we want to do is to make sure that there's interactive participation by the audience members. So I'd like you to make sure that you confine your questions to the topic of technology adoption. If it's something that's on a different topic, that's fine. Just save it and maybe we'll connect you to a specialist in that area. And in the meantime, also, I'd like to say that after we have our panel on technology, we'll then have an actual example of a technology that's in the process of commercialization and basically a new technology that is up and coming. So that will be a lot of fun. So we'll have a chance to talk there too. And then we'll have a roundtable where you can send things in the chat and we'll talk about them. But then we'll also have an opportunity to, if you have a technology that you'd like to share or an example that from technology adoption, we'll do that. So as we get started, I'd like to introduce our panelists today. First, we have Amy Henry of Eunike Ventures. Say hello, Amy. And we have John Thurmond of Hess, of Sudhir Pai of Technology Collaboration Center, and Sunil Garg of DataVedik. So welcome. Hi. And then for our new technology showcase, we have Ellen Scott Williams of Exum Instruments. So we have a wonderful, wonderful group today. So I'd like to get started by asking Amy to basically kick us off and talk a little bit about what you do.
Sure. Let me just quickly pull up my screen here.
And just as a reminder, we're going to be doing 5 minutes. And so when we get about 4 minutes in, I'll just let you know.
Okay, perfect. We're Eunike Ventures. And so we were officially launched in January 2019. So, we really focus more on the startup as well. We're from industry. So it's about how do we extend the runway for our startups, getting pilots and getting smart capital and extending the runway to increase adoption in the industry overall. And so I really kind of want to start with, kind of one slide here quickly, because we really never talk about this, but really at the end of the day, we all talk about innovation. But really the struggle with adoption is just not the technology itself. It really is the behavior, right? And I just threw a couple of samples up there, just a reminder. If you look at the left side, the increasing pace of technology is changing, but then, really, organizations change at a much slower rate, right? And so for some companies, you have that kind of someone in between those two layers, from a technology team or the CTO, and they're helped to kind of push those gaps closer in, right? But, a behavior we don't talk about a lot in the industry, but that is such a big component. Okay, so, I thought I'd start with, we talk about, field trials, pilots, proof of concepts, and I think we all kind of stick to kind of our traditional, kind of vision of how it's traditionally been done in the industry. But a lot of things have changed. There've been a lot of big changes in ecosystems, models, and global markets. So, I thought I'd give some just, practical examples like at Unique, right? Even though we have an alliance with industry partners, we work outside of our alliance and we work further as well. It's about partnering and collaboration. So, Toku was one example. Hess is one of our partners and they belong to iPipe. So, we like the technology, Hess liked them. And so we pushed them over into the iPipe industry association, and they currently have a pilot. What are other ways? So we have a partnership with Epicenter, which is based in San Antonio. They're a utility downstream backed accelerator. So, we had a group this year of these particular companies. Some came from Israel. We really like them, not quite ready for upstream applications. So we put them there with our kind of sister affiliate, and they're looking at them, and they'll most likely, one or whoever kind of meets their criteria. We keep our eye on them, track them, and then see how they develop, and then we try to bring them back upstream, right? And then there's other avenues where we have, two really solid, companies, but we think it's more practical for them to come together and come up with a joint value proposition, right? Which will enhance, a pilot, which will help them further, going through that adoption process together. So that's one way. We work lots of other ways. It doesn't start there. I mean, it really starts at early stage, right? So I threw some companies here. These are very early TRL 2-3. We could be game-changing technologies. What do we do? If we like the technologies, we talk with our partners. We'll send like a letter of interest and support to the DOE and RPE, right? Aeromine, for example, received a $2 million grant. With Tri-D Dynamics, with some of their smart pipe technology that they're working on, has also, and along with this, saw some really good future application. So, Hess had provided an SME to sit with them on their advisory board, right, to kind of help them as they're going through this process. Well, then there's some companies like EquipCast, for example. It's a digital company. They had 3 trials. Problem is, they needed seed capital in order to be able to start to execute on those field trials. It becomes a chicken and the egg. So Unique, for the first time, provided seed funding along with one of our Thai partners and another retired oil exec to help them start their 3 field trials, which were happening outside of kind of your upstream. They started first in midstream. And then we have other companies like Sensalytics where we work with them, and this one was done with Hess as well, where it's more of a bench test, right? They provided some free work. They worked together with the Hess team, and further developed the business use case and did a mini pilot. And then this is what we're working on taking one of our long-term relationships with Canada and extending that. How do we extend these energy bridges, right? So that we can provide more field trial and pilot opportunities to company. It's a global issue, not just, industry here. So with Foresight, they're a clean tech accelerator in Canada, and they're responsible for building out the platforms and clusters. So with our partnership with them, we're creating what I call a bilateral bridge between the two. And so that provides field trial opportunities for our startups to go to Canada, and likewise, it provides more collision between startups. And as well as, we're also working together as how do we extend this runway, provide that early stage funding that these companies need, and getting a higher level of adoption. So quickly with this, I'm going to skip this page. And so we're jointly working on a program together. So how do we create a seamless platform for a startup, right? So they already have a kind of a formalized program there in Canada, and they didn't have the aspects that we worked on where we start with MVP to pilot. So what it's doing is Foresight goes all the way up to kind of the acceleration mode. And then we work with them through that process so they can learn like what are the qualities that we would look for a company that's an MVP stage, and what do our industry partners want. And then it's kind of somewhat of a kind of a pass off point where we take and then continue to work with those select startups and then take them all the way through, field trials and commercialization process. It is providing a seamless end-to-end platform, right? And, and this then fits into, definitions. So when we first started working, they were defining clean tech as, hydrogen, CO2, CCUS. But we said, we do think those things are important. But when we look at technologies, if we look at our traditional energy value chain, right, there's also linked to that ESG. There's quick wins that we can do operationally that will, from a digitization, create efficiencies, reduce the carbon footprint that we can do now, right? We can't look at these things separately. We have to bridge them together. One cannot happen without the other. So I think this is a great opportunity. And then, we're really pushing people saying, you can't just say I'm doing field pilots. We got to get people to start having some measures, don't do pilot. We see a lot of people doing pilots for the sake of doing pilots. At the end of the day, how do you measure success, right? And so it just takes time, and it takes more people to kind of pitch in and make some of these fundamental changes. And I'm done.
That was good. Wow, you covered a lot in 5 minutes. So that's wonderful. We have time for a question or two. Any quick questions? Okay, so here's a very involved question. Many of and you might just answer like a part of it, but many of the companies you were talking about are more advanced than the operating companies they sell services to. That's interesting. Can you talk about how you see oil companies evolving to meet technology?
Well, actually, I mean, I have one interesting story, but I can't really tell the name. But it is a much smaller oil and gas company. Actually, their SVP had reached out to us because they were having discussions at the board level of, what were they going to do to try to tackle kind of ESG, right? What was the best approach for them? They were getting asked more and more questions from the shareholders. And at the time, we actually knew a startup that was discussing field trials for them. And it was operational. The operational team really wanted to take on the technology. The issue that they were facing was middle management, getting middle management to buy into this. So we talked from the top organization and getting them to, they actually stepped in, which is not done a lot, and to talk, and they went down to the field level, right? Because there were ESG improvements that were associated with just tackling a production kind of optimization, and this is kind of like an Internet of Everything approach that they were doing. And so it was bringing those two together, right? And, you may think that they're small, but then because they linked those two efforts together, I mean, we kind of push that, right? That's where you can make it really, and also bringing the economics into it. So getting companies to look at the R&D tax credits, right? It's really heavily underutilized by our industry. And so, if it's done properly, that provides a return on investment on the field trial itself. So it's reminding companies there are economic incentives, even to take on small scale field trials, right? Sometimes you got to start small.
Yeah, that's good. Well, that's encouraging. And I think one thing I like about what Eunike does is that they find paid trials. And so it's just a win-win all around. So
and what was good about this example is because they had 3 trials and they happened to be very close in terms of location. What they were able to do is really put skin in the game and offer those field trials at, I think ridiculously low cost, right? I mean, because they had economies of scale. So where we can, and we can try to get parallel pilots going at the same time, that enables more companies to take on those field trials, right? Because we're bringing that cost element down for them as well.
Oh, that's great. Wonderful. Well, thank you. And we'll have some time at the end for more questions. But I'd like to move now to John Thurmond of Hess. And John is a principal advisor And he actually is in charge of selecting companies to field trial. And you might tell a little bit more about what you do, John.
Sure, I'll absolutely get into it in the presentation. I just want to preface this by saying I promise I didn't pay Amy to say all the nice things about Hess and talk about all the pilots we're doing, and also set up my presentation so well. Well, at least I didn't pay her directly, maybe indirectly. So, yeah, I mean, I'll tell you a little bit about what I do when we get to that part of the how we're doing this at Hess, because that's an important part of this. But look, the only constant is change, right? You hear that, it's an adage you hear all the time, but let's be honest, pretty much everyone wakes up every day thinking that today's going to be more or less the same as yesterday, right? And when it's not, it's usually an unpleasant surprise. You know, humans have a fundamental resistance to change that's hard to overcome. And Amy showed that in her first slide, right? You know, so this is a constant uphill battle for anyone who wants to implement new technologies, because even if you can overcome that resistance to change yourself, you need to bring others along on that journey or to fail. So, and I'll tell you from my own point of view, I watched a YouTube video a few years ago as a TED Talk. Actually, it was more than a few years ago because the year I turned 40. And it was on how to tie your shoes properly. And yes, there's a TED Talk on how to tie your shoes properly. And if you've ever had a constantly becoming untied, or you've been with somebody who do that, they're tying it wrong, the way and a wrong way. And you know, you should encourage to watch the video. But I watched the video and realized I'd been tying my shoes wrong my entire life. And I set out at the age of 40 to try to tie my shoes in the right opposed to the wrong way. And I tell you, retraining yourself to tie your shoes, something you don't even think about all the time, you know, you just do, is really, really hard. And that was a useful exercise because that's the kind of change we ask people to do all the time when we want them to implement new technology. The way they've always worked, what they do on a day-in, day-out basis needs change. And asking them to change is hard, especially when people have done it their entire life. So that was a really important lesson for me to understand how hard changing something even small like tying your shoelaces can be. You know, and you know, it's often said that handovers where innovation dies. You know, the resistance to change, why, and that has to be managed. So another point is the pace right now is increasing. If operators like us aren't constantly striving to increase the speed of adoption of new technologies, we'll fall behind. And you know, I think one of the questions earlier kind of highlighted this. Operators are traditionally really slow with this. Big part of it is that resistance to change, right? So these two factors make for a real uphill battle in this. So really what you're here to hear is how are we doing this at Hess? So first we have a sharp strategy in the areas where we want to improve. We want to increase well and field productivity while decreasing costs. This is something we call 10X. Second, we want to increase automation. We want to make operations safer and drive down costs while increasing productivity. You know, this is something we call automated fields of the future. We want to get more out of our data. This is something we call data is the new oil, or dyno power. I guess we can't say that. That's a Sinclair thing. But you know, that's a good one. And we want to find ways to make things in new and cheaper ways. This is something we call preferred parts partnerships. So the second thing we do is we have an organization, which is what I'm part of, set up to relentlessly scour for new technologies that are in these four areas. And really importantly, we have the freedom to think about and demonstrate real step change technologies. And that freedom isn't always there when that innovation function is distributed into the assets or into the disciplines. So the third thing we do is we have external partnerships with organizations like Eunike and others to help us scour for those technologies even more relentlessly, right? And that also helps us work in areas that are adjacent to oil and gas, where we're less familiar, and we rely on these companies to identify startups and flag them for us to say, hey, maybe this is something you should think about. So we have a central clearinghouse for new technologies that we use to mine when new business needs come up. That's fed by those external providers and things we discover as well. And this really helps us because it allows us to manage our interactions with external companies in one place, so we can avoid duplication of effort. And we all know the case where, technology providers will try to get in the door, 18 different ways. And we have this in a central location that allows us to understand who we've talked to and what our view is of it, and makes us faster at decision making there. And maybe the most important thing we have is a constantly evolving process for initiating and executing pilot projects. This goes from selection right through to full-scale deployment. It evolves because we're constantly trying to make it faster and more effective. It's definitely not a right answer, but there's almost always a faster and better answer, right? And to get to Amy's point about pilots, we measure what we do in that space because you can't improve what you don't measure. And what we have to do in order to keep up with that pace of change is do a lot more pilots, do them faster, do them more effectively, right? And get those through all the way implementation, which is hard. So our mantra here is experiment, learn, adopt. We try things, we learn. Whether something works or it doesn't, we learn either way. And if it works, we adopt it. And the faster we can do that, the more people that we can get involved and enthusiastic about it, the better chance we have of keeping up. Maybe we can even get ahead, if we're lucky. That's really how we're hitting those two barriers head on. So those two things I mentioned up front, the resistance to change and the speed of adoption. Those are the tools we have in our toolbox to do that. And we have, like I said, an absolute relentless focus on trying to do that better and better and better to try to get ahead. So that's it for me.
That's great. Well, I really appreciate that, and really nice insights. I noticed that Amy has responded to some chat questions, so be sure to check the chat box because there's some really good information there. And anyway, here's a question for John. What has had to change at Hess in order to adopt the rapidly advancing technologies on offer? Are there other companies and industries you look to most for guidance?
Yeah, I mean, the fundamental thing that had to change is it's very easy for companies to get in that same state of resistance to change as we do as humans, right? Because the company thought process is ultimately made of humans, and we all kind of have that, and it's easy to fall into that stuff. You really have to be challenged and pushed to change. And, I think, Hess went through a few cases where we realized we weren't keeping up with technology as well as we should have. And that was costing us. And that really opened the eyes of the senior management. And they said, look, we have to do this. We have to have a relentless focus on technology and moving things forward. Or, we can't be as good of a company as we can be to our shareholders, right? I mean, that seems like an obvious thing and a simple thing, but it's very easy to move away from that and keep your eye on other things like, production targets and all the things that operators are normally concerned about. It's easy to say, hey, we don't have time to test new technologies because we need to actually drill this well and, get the oil out of the ground. You've probably heard that a lot. And what's had to change is really an understanding that this is an important element from top to bottom. But I'm not gonna lie to you and say that the culture is all fixed there. Slow process to change the culture of a company there, and that's one of our huge points that we have to work on constantly. Is, like I said, how do you get people involved and enthusiastic about the change that has to happen, and how do you set up pilots that allow them to participate in that and be a part of it and bring things forward, and that's the culture you need to constantly be sort of improving and doing things better. In terms of companies and industries you look for most for guidance, it's hard, right? Because everybody looks to innovation on the innovation front to software companies, and it's just fundamentally a different beast, right? I mean, when you have to sink, $1 billion into a platform for production, that you're not going to get out for several years, it's really hard to do that in an iterative fashion. We don't build a platform and then disassemble it and reassemble it to make it better, right? That's not how it works. You really have to think through some of these things in the longer term. And that means that as much as we try to be agile in certain areas, there's certain things that have to be waterfall, right? And, it's difficult to pull lessons from other industries. That said, we're always looking at other industries and trying to learn from what they're doing. I just think some of those lessons are not a one-to-one translation always.
That's a really good point. And we have another question in the chat, but we don't have time for it right now. And I like the point that you're making about that we learn from other industries, and also that there are just applications that can't, well, for example, your example of offshore platform development. Once you're on that trajectory, it's really hard to make big changes. And yet with some other things, you can make massive changes along the way. So understanding that up front is an interesting issue as well. But okay, so talking about learning from different industries, we have Sudhir Pai from Technology Collaboration Center, and he brings together space and medicine and energy. So welcome, Sudhir.
Thanks, Susan, and good evening, everybody. So listen, this is absolutely exciting discussion, and I can now see, Susan, why you put me behind John, because I can just take some of the stuff he is talking about and move ahead. In the interest of time, maybe rather than showing slides, etc., let me just talk to them because I like this. I'll just continue the trend which John has set up here. And I'll start by making a particular statement which was made by a well-known scientist, and I try and use it as much as possible wherever it's relevant, and that is, and it works in lots of things, and that is the answer to my problem might be in my neighbor's toolbox. Yeah, and with this comes sharing of technology and things like that. So very quickly, I won't go too much into what I've done in the past, but right now I'm the chair of an organization in Houston called the Technology Collaboration Center. And we try and see how technologies which can be shared between various industries can find success through it and try and build it. And when we say various industries, we started with 3 key industries. And originally, the Technology Collaboration Center, which was started in 2014, was started by a need for NASA to outsource some of the technologies that they needed in general, but particularly from startups, etc. And while they were busy focused on their key mission, the idea was this be handed over to who can basically take it and use that as a platform to help them get there. A 5-year SAA, Space Act agreement was set up, which went from 2015 to 2020. And based on the success of that 5-year agreement, earlier in 2020, we went ahead and the director of the Johnson Space Center, Mark Geyer, and I went ahead and signed the new 5-year agreement, which goes all the way through till 2025. The idea is to continue to collaborate with NASA on various technologies, and again, bring in 2 other industries, energy and healthcare. While we in Houston might be, it might be known, although the more I ask, people forget that there are more doctors in 1 square mile called the Texas Medical Center between Fannin and Maine than anywhere else on earth. So here lies this strong connection between those, yeah. And I loved the picture, Susan, which you had put up for today's session, the lovely handshake between human being and robot working jointly towards technology. So hence, the entire kind of this today, I thought I'll focus on some of the work that the Technology Center has done very closely with NASA, Johnson Space Center, and JPL, Jet Propulsion Lab. And I'll touch the 2 or 3 things that in recent times we've worked on. Yeah. So I was part of the robotics team, which was set up by the city of Houston with one of the heads at NASA there. And we had the chance to go and look at a robot called Valkyrie. Again, everything that I'm speaking today to benefit the audience is public information. Please go back and Google. And Valkyrie was an interesting semi-autonomous robot with the ability to have articulating hands and the ability to send this as part of a interpretation to areas where sending humans should be the last resort. Send technology out there to do various things, etc. And I have this lovely picture of me actually shaking hands with Valkyrie, and Valkyrie sensing the fact that somebody is actually shaking hands with him, similar to the picture that you have, Susan. This is not just a toy. Out of this comes a whole bunch of new technologies, etc., which are going to come through. So robotics is a key in various forms, is a key technology we deal with, NASA. Another key one, and something which is close to my heart, because in the oil and gas industry, I worked for Schlumberger, and day one as a logging engineer, you log. So the term imaging is very close to your heart. Late last year, we did something which has never been kind of done before, wherein we had experts from NASA. So NASA was represented by Donald Pettit, an astronaut who's been on the International Space Station, but closely associated with imaging, who works very closely on the effects of microgravity on vision, medium, long-term and short-term, and try and see how you can use imaging for that. We had Juan Lopez Matei from MD Anderson, radiology and imaging department there and cardiology department there. And then we had Dr. John Etchen, which a lot of us know, the advisor from BP. And it's interesting, each one was coming from 3 different industries, but attacking the same problem, that is, how can you use imaging to find faults or increase long-term sustainability of life, yeah? Life in terms of human being, or life in terms of the technology that we want to get. So an important aspect that you can use there. The third a quick example I'll use is the fact that, and it's, I think, fairly close, should be fairly close to some of the things that AAPG does. And this month of February is an extremely important month, particularly the time around the 18th to 21st of February, where from the project Mars, the rover is going to go and go to Mars to characterize the geology and the habitability of the site, to look for signs of ancient in rocks and in soils, to collect scientifically compelling samples and collect them and keep them in situ condition to be returned back home, back to Earth at a later time, and take all of these lessons learned for future human exploration on Mars. Here is where some of the lessons learned from what we do on Earth subsurface is going to be extremely important as it goes ahead. It's identified an area called the Jezero crater, where Mars Perseverance rover is going to land, and I think it's going to be super exciting about the things that it's going to do. And there are something like 23 cameras on the rover, 9 engineering cameras, 7 scientific cameras, and 7 entry, descent, and landing cameras as the rover comes down at 1,000 kilometers per hour, and then lands nicely on the northwest area of the Jezero crater, which is in the northern hemisphere. It's a multi-country program. For example, Norway is providing the subsurface radar. France is providing the laser micro imager. The weather station is being provided, I think, by Spain. There is the MOXIE oxygen system. There is a full sampling system. Reminds me of the modular dynamics tester that I used quite a lot in collecting samples, etc., and the CST, the sample catcher. So I think it's going to be super exciting times as this go ahead and explores and collects this data and sends back to us. And for once, I think the energy industry is going to be hopefully assisting that mission to try and see how we can work together to share the lessons learned. So exciting times on stuff done from before. And I think what's going to happen in the next few years as Perseverance does the acquisition, and then also another mission will go out and collect those samples, bring to Earth, so we can continue to do the unmanned stuff on Mars before eventually humans go there, after having gone onto the International Space Station, onwards to the moon, and then continue on to the Mars. Yeah, so exciting times coming ahead in the future.
I'm so glad you mentioned that, because just coincidentally, AAPG has an astrogeology committee, and we're going to have a rover watch on February 18th. So I'll send you everybody an invitation. We'll have we'll have a former astronaut talking and members of our astrogeology committee. One works for NASA somewhere.
Correct, that's right. So it's going to be exciting. It's one of the reasons why I wanted to take that as the topic of discussion today, away from other things, because I think February is going to be a very exciting month for the start of some lovely things which are going to happen, which I'm sure the core domain of AAPG is going to be super excited about.
Yeah, absolutely. And I'm also really glad that you mentioned collaboration. So this is a nice segue also for me to be able to talk about, before we move to Sunil, to talk about the fact that we are partnering with Srathis, and it's a collaboration platform. So I'm going to put in the text box, and Rekha Patel is here today, so she can put some texts in the box too. There are collaboration clusters that are set up. And Rekha, would you like to mention it really quickly, and then we'll move to Sunil?
So Srathis communities are set up for communication and cross-vertical and cross-disciplinary collaborations. AAPG has built their own little collaboration platform there, where Susan is actually announcing all the pivoting series information. And each one of the talks has a related what we call clusters. It's a discussion forum related to it. So you will find the information there. You can come in there and talk to each other. At the end of the talks, Susan is also posting her videos there. And as of last week, she has decided she's going to post some challenges for us there. So if you go there and visit last week's talk, then you will find that she's got a challenge that she's posted there. I don't know, Susan, if you are putting any timelines on it or you want that to be open, but you might want to talk about your challenge.
Yeah, so but basically there are challenges where you can imagine that you are in a certain situation and what would you do to solve the problem. So in the first one, we talked about responsibly sourced gas, and let's say that you were hired by a company to make sure that their gas was responsibly sourced. That is to say that what they're delivering is they have monitors, their sensors, they're controlling emissions, monitoring, and they're not flaring. And so you're charged with that, and also you want to help the business unit provide value. So they're just hypothetical sort of scenarios or challenges so that you can share the ideas, what you would do to create some brainstorming ideas and workflows in the challenge. And it's meant to be interdisciplinary and a place to network. So anyway, those are where we're getting started, and we'll just see where it goes. We'll also have what we call our technology hut or innovation hut. So that we'll post, like, for example, Ellen can post and put her links to her information in the technology hut for this show or this week. So anyway, so thank you, Rika, and we'll move on now. We'll speak with Sunil. And if you have any questions about anything, just put the questions in the chat box. So thank you. So Sunil will talk to you about your experiences and perspectives on technology adoption as well.
Thank you, Susan. So let me share my screen. And what I will do is I will kind of share a few slides just to set the theme for this talk. So let me just quickly go into the slideshow mode here. So as Susan introduced, I'm the founder and CEO of DataVedik, which is a Houston-based startup focused on sustainable living. And what we do is we specialize in big data and data analytics for energy industry. That we use the power of big data and machine learning essentially to focus on value-added workflows, let's say, for the energy industry. And our mission is essentially, this is how we started basically. Our mission is to help the energy companies with cost reduction and optimization, and at the same time looking at energy transition, which is a lot of the focus on the side of oil and gas companies, and also carbon footprint reduction. And we do all of that by kind of optimizing the operations across their life cycle. Right? We use heavily AI and machine learning in order to achieve that objective, but a whole lot of it is also achieved using the domain knowledge that we have. Right? So what I'm going to talk about today is a little bit how technology collaborations and partnerships have evolved over at least since the time I started the startup, which was in 2017. Okay? Before I do that, right, just a few focus areas that we focus on. Right, you can see, some of the areas are around cost optimization, improvement of the safety, but also around energy transition and carbon footprint reduction. At the end of the day, everything boils down to how can we make faster and reliable decisions. And this is basically, I would say, is going to be the theme of what I will say about all the collaborations and partnerships that we are doing. Okay, so let me go further. I'm going to skip this part. Let's go to the main thing. Okay, so here is, that went too fast. Sorry for that. So here is kind of, what we observed, right? So I started the startup in 2017. And of course, at that time, one more, a whole lot of focus was on, companies and vendors or service providers. And what we have seen is that kind of relationship has evolved, especially in last couple of years, some due to market conditions, in the oil and gas industry before COVID hit, and whole lot due to the market conditions that have changed drastically since COVID-19 hit, right? That there is a lot more talk about partnering and collaboration. And I'm going to take a few examples of that from my experience, in fact, right? So one is with oil and gas operators, right? More and more what we are seeing is the goal of the projects and the pilots and the actual deployments is lesser saying, well, can you prove that something like this will give me a financial benefit, to can we work collaboratively together towards a particular objective, right? They kind of, at the end of the day, probably achieve the same thing, but the message is very different. Message is that we are sharing the risk and we are sharing the success and the failure of the project. Right? That makes a huge difference for a startup specifically. That makes a huge difference because there is learning opportunity on both sides. And when the objective is collaboration, right, it's kind of learning with an open mind. It brings a whole lot of innovation in a much better way than you could do in a, let's say, supplier or vendor relationship. Same kind of thing I would mention with oil field services companies. And I will show you another example with that in terms of, how basically we started working on one of their initiatives and how it rapidly expanded. So I'm going to go to the next slide. Okay. This is a testimonial from a OFS IoT company. In fact, I put the name there. This is from Schlumberger Agora, which is a IoT company that Schlumberger started. It operates more like a startup. We built something in partnership with them. And when they were giving us a testimonial, right, what I wanted to share really is the theme of that message, right? You would see, this is verbatim what they said, right? You can see how they say where DataVedik worked in collaboration with Agora, right? That matters a lot. When a client shares that kind of testimonial, that essentially tells you, the power of the collaboration, right? Same kind of message is from a OFS tech startup. This is a well testing startup. Their focus essentially is doing production testing in real time. And again, what you will see in the message there is the same kind of theme, right? Collaboration and how we work together in partnering with them, right? Where they could use a part of our technology and some part of what we developed for them, essentially to bring together a solution that works well for their operations. So that again, like I said, right, the theme of the testimonial or the language of the testimonial mattered to us a lot, because when we saw that, we said, okay, this clearly tells, what is the nature of the collaboration, right? Similarly, you saw on my earlier slide, there was mention of, if I go back to that slide, there's mention of private equity players. Right? And this kind of relationship started with one private equity group more from a technology advisory perspective. And while we were working on that, and the reason we were giving them technology advisory was because we have expertise in certain technologies, and we also have deep expertise in oil and gas data. And they were trying to invest in those kind of startups. Right? And that relationship slowly evolved into, why don't we look at their portfolio companies and work with those portfolio companies in collaboration to provide specific business objectives. So this is essentially, relationship starting from one thing going into another thing with their portfolio of companies. So that was also very interesting. Here is another example that I will show you. Okay, so this is what I call as real-time drilling performance analytics. This started with something that we were building as part of our drilling optimization platform at DataVedik, and we got into collaboration with a drilling company. And they looked at this and they said, oh, we have been trying to build this. Why can't we build this in collaboration? Right. So it's something that would give them benefit and something that would give us benefit at the same time in terms of evolving our product. Right. So what you see on the screen is, kind of a mashup of the full, let's say, workflow, which was built in 3 weeks' time in collaboration with them and with the real users, giving them feedback on how this could become useful. Okay, and that started, like I said, with the 3 weeks, a very small pilot, very short pilot, where they were able to see the value and grew into a pretty big initiative. Right. So again, that spirit of collaboration and partnership mattered a lot in this kind of initiative, and it slowly grew. So those are some examples from, let's say, the things that we worked with our customers. I wanted to give you one more example, which is around the industry collaborations. And I think OSDU guys were there in one of these forums presenting. So OSDU is Open Subsurface Data Universe. This is essentially an oil industry initiative in order to build a common data storage and API platform on which all of the applications in oil and gas industry can run. Started more as an upstream initiative and is going to downstream, and is also now spreading to the new energies, which is carbon capture, solar, wind, all of that, right? So on my side at DataVedik, we were building, this drilling analytics platform, and a whole lot of things, in drilling analytics has to essentially do with real-time streaming data. OSDU was trying to build a real-time infrastructure for all of the different data types, including drilling, production, also new energies. And we became members of OSDU about a year back. And when we looked at that, right, they said, we want to start this, and they started looking for a team. So the end result of that was that I'm now leading a team there, which is basically building that real-time collaboration, which will not only help, At the end of the day, it helps DataVedik because we were trying to build this anyway at our end. It helps OSDU because we are contributing what we have built already, and the knowledge is part of that initiative. So essentially that kind of, becomes an industry collaboration where a bunch of us from different companies, including oil and gas operators and including service companies, even the cloud provider companies, are working together in a team trying to build this for the entire industry. Another example of that collaboration, which I put here, I talked about Agora more as a customer where we did a collaborative workflow. Now we are also present in their marketplace with our drilling optimization solution. So that kind of, is a different, you can say, angle of that relationship, where Agora as a marketplace, they want to basically work with the startups, kind of sharing startup solutions with their customers. And we are on that marketplace where we are showcasing our drilling optimization solution. So that's another, I would say, angle of, how that partnership grew. And I can take a whole lot of examples, with different organizations here. AAPG, of course, is very close to my heart. We do a lot of work with AAPG and with Susan. In fact, right, we have done lots of, I would say, machine learning hackathons, trainings as part of the AAPG conferences. And we see a lot of demand for that kind of thing in terms of sharing our knowledge and sharing the technology with other people. Right? So those are, I would say, some of the other examples.
Well, thank you. Those are great. And I can't believe how nicely this all flowed together. And I'm so glad you focused on collaborations. And I just wanted to point out just really quickly that interdisciplinary real time, and that it's made possible because of cloud computing and the way that we can approach things we couldn't before. So I really appreciate it. So look at the time, and we have time for one quick question. Perhaps I'll circle back to John from the operator perspective. So John, I have a question for you. So everybody's talking about the importance of collaboration and also kind of attuning or aligning to real world needs. How do you do that at Hess?
Yeah, particularly the last part, aligning the real world needs, it is a constant struggle in any kind of innovation group to balance the immediate needs of the business versus longer term changes, right? And we have to focus on both, really. You hear a lot from different technology groups that they focus on one or the other. And it's really hard to do that. You really have to consider both angles. And what we're trying to do is really collaborate with the business units. We have three categories of pilots, right? There's improve, cultivate, and transform, right? And so the improve are the more small change kinds of things that are improving day-to-day business, in the assets. Cultivate is more of a step change. Transform is just what it says on the box. It's a real transformation in what we do. And on the improve projects, we really want to encourage the assets to do that themselves, right? So we're trying to build into that process the ability for them to pick up things and do that quickly, right? And enable them to work faster and faster in that space. So that gets them more focused on solving their own business problems without sort of having to go to an external group. We try to focus on kind of that larger scale step change stuff. Sometimes we have to do a little bit of the improve as well, but for the most part, we try to hit that. So it is tough to balance. It is tough to collaborate across a company in those spaces, but we do try to do a lot there to smooth things over and make things better and faster.
Oh, that's great. Well, this is really good, and I do see that people are typing more questions, so we'll keep those in mind. And there's one for Sunil that we'll answer after we have our presentation from Ellen. So I'm thrilled to be able to introduce Ellen Williams of Exum, and welcome.
Awesome. Well, thank you very much, Susan, for having me and for allowing me to talk about Exum's technology. I did talk briefly at the holiday technology showcase or whatever that was called back in December. So some of you may have heard a little bit about our new technology, but this will allow me to go into it in a little bit more detail. But what we've done at Exum, you can see our brand there, Science Simplified. We've tried to bring analytical performance to people who don't just have PhDs in analytical chemistry. And we've been gaining a lot of traction, not only in the oil and gas industry for characterizing rocks, but since we can analyze any solid sample, you can also analyze, a metal alloy for the material science. You can analyze a piece of a battery for another energy source. And so we're able to use this very simple, elegant design in order to get great results without too much chemistry involved. And so if I go to my next slide, what this is, we call it the mass box because as the slide shows, it is just this box. And it is a laser ablation, laser ionization, time of flight mass spectrometer. And I know that sounds like a mouthful, and I know it's late evening, so I'm going to explain that by showing some aesthetically pleasing videos to talk through this technology. So as I mentioned, everything is contained within just a 2 foot by 2 foot by 2 foot box. So we were able to compact all of this high technical power into something that can be brought to maybe a field office, maybe a well site, maybe a manufacturing plant. It can be used for both organic or inorganic analyses. And so I can answer questions on that, but I'm not going to go into it too much here. All you need is a power cable. So again, it fits up on a desktop, you plug it in, no need for extra vacuum pumps or gas bottles or anything else. And so you can see that we've got the sample holder open. And in this pretty video, we're throwing a quarter in there to analyze. Again, anything solid with a relatively flat surface, we can analyze. We'll start by taking an image with the macro camera. And another benefit of being a new technology is that we've borrowed from smartphone user interface technology. So we have a intuitive, easy to use touchscreen interface. You can mess with it with your fingers, zoom in if you want, choose your points for analysis, and then click go. And it does pump down to a vacuum environment. So this entire process is done under vacuum, which means we don't have some of the same ion losses that you might find in other mass spec techniques. And so here's where the magic happens. So here's that first laser, that laser ablation that happens perpendicular to the sample surface. So that's going to ablate or liberate just a small amount of material. This will generate both a plasma as well as some neutral particles. And so what we're doing with our second laser, that ionization laser, is we're ionizing those neutral particles rather than the plasma that some other mass spec techniques do. So those neutral particles are more representative of the characteristics of the sample, which allow us to get better results. So then once we've got ionized material, they're going to go up through our ion deflector, go through a series of ion optics to our time of flight mass analyzer. So like the name suggests, what it does is it measures the differences in the times of flight for all these different ions based on their different masses. So if they all have the same energy, then their different velocities and the time that it takes them to impact this detector will depend on their mass. And so that allows us to get this full mass spectrum in each analytical session that then allows us to know what constituents, if we go to our periodic table, are in our sample. So you can see here, this is a graphical representation of our detection capability. So you can see our technology at the top. Each element is colored by its detection limit, with the cooler colors, the more blue colors, being down into the low parts per million, even parts per billion level, and then those warmer colors being a bit higher detection capabilities. And you may recognize some of the techniques here. So for example, XRF, commonly used in the oil and gas industry, what we're getting is higher sensitivity as well as more of the periodic table. So even identifying some of the elements like carbon or nitrogen or oxygen. And again, for any for any application that uses a solid sample that you might want to understand the elemental composition. And so this is great for bulk characterization. So say you've got a rock that you just want to characterize and understand what it is. But what if you've got a really heterogeneous sample? So the other thing that we can do here is chemical mapping. And what you can see are two examples of a 5.5 millimeter by 5.5 millimeter sample that we analyzed. And each one of these, so our laser size was 11 microns. So we have over 250,000 laser spot sizes here, which again, each one is generating a full mass spectrum. So you can look and see how any of those elements are changing in a map view and then even in a depth view. So if you do a couple of different slices, ablate off the sample surface and then take a look at the surface below, then you can start to identify maybe some surface contaminants as well. And in this case, we're actually looking at a lithium garnet, and this sample had been adhered to some aluminum foil before it was given to us to analyze. So that's why you can see the aluminum concentration shown in red. Once we ablate that sample surface and go a layer below, then we're starting to see less of that red, more of that zirconium and lanthanum, which were actually our matrix elements here. So I think I may have gone a little bit over, but thank you very much for your time. I hope you enjoyed some pretty pictures and some videos this late in the evening, and I'm happy to take any questions.
Oh, that's fascinating. I really, really like this. So are there any questions in the chat box, or would anybody like to open their mic and ask a question? If not, I have a few questions. Okay, so my first question is, how do you think that this could be used for somebody wanting to start or expand their existing business, start a new business or expand their existing business?
This particular technology?
Yes.
Yeah. So there is kind of a high price tag. It is in the hundreds of thousands of dollars. So if you were just starting out, then you may not want to make that upfront purchase, but it can give you some autonomy so that you're not having to send your samples of whatever it is you're manufacturing or trying to measure for quality control. You don't have to send that to an external source, maybe a lab that has a team of PhD chemists and a big mass spectrometer in-house. What you can do is it can speed up your development and help you innovate with new materials, because you're able to get these answers quicker and in-home rather than sending them to an external lab. And again, it's much more intuitive, and you don't need to have a PhD in analytical chemistry to run it. So it could kind of help you accelerate your materials development or whatever new technology you have. But I would say that it maybe wouldn't be the first thing that you buy. It might be a little bit later in your new business.
Well, that makes sense, especially if you have a lot of things that you must inspect, and it has to be accurate, and you have to do it quickly. So it really makes a lot of sense. Okay, so Ellen, can the box capture fine scale visual images from layer to layer? I'm thinking of the relationships between composition and permeability, for example.
Yeah, that's a good question. That is something that we're sort of we're running a lot of different samples for a lot of different industries, so that's kind of something that we're exploring right now. But I mean, what we're getting is ions that represent the sample matrix. So if there is maybe a void space there, I don't know that we would, and it does not yet work on liquids. So what we might see is maybe the salts that have been deposited of those liquids. So in terms of traditional images, still yet to be explored. In terms of permeability and sort of composition. So to be continued when I have some more data to show, maybe.
One of the things I think that it would be extremely useful for is in 3D printing and additives manufacturing for quality assessment. So for example, there's a company, they're going to be presenting later in the series, Evaldi. What they do is they are putting together a repository of files for sending out to qualified 3D printers and additives manufacturing. Now, okay, the big issue there is, yeah, it's like print on demand, but this is like where it really, really needs to be inspected, and it's exactly the area where, I mean, what are the bonds? How well are they? How are the lattices, for example, in additives manufacturing? I see huge potential there.
Yeah, we've actually done a lot with additive manufacturers and talked to a lot of them and gained some interest. This is just an example of our sample tray and kind of all the different materials that we have experience running. And so, like, for example, up in the top right corner, these are alloy powders from an additive manufacturing company. And so analyzing their feedstock and making sure, okay, yes, this is meeting my specs of what chemicals are supposed to be in it. And then when you get to a finished product, so for example, this is like a copper alloy pressed pellet, and then this is a copper cube down in the bottom right, and then you can just double check it one more time, like, okay, did my additive manufacturing process change the chemical composition in any way, or am I still getting my expected materials? So yeah, that's exactly a great application for this instrument.
Oh, cool. Yeah, that's nice. And with the additive process, just it would have a chance to look at every single layer. And I just love that. So interesting. Well, great. I don't know, did you see any questions in the chat that missed?
Patrick asked about how clean the samples will have to be. I assume you mean maybe like if there's oil-based mud or something on them. So I guess that's why we tend to do multiple sort of raster lines or maps over the same area to compare that difference between what's on the surface versus what's a bit below the surface so that we can get rid of any of those surface contaminants. And then William asked a question about talking about the innovation process and the challenges we had to creatively overcome. Yeah, I mean, we're currently working from, we commercialized this back in March of 2020, which was a great time to commercialize a product. It was at PitCon, one of the big conferences for analytical equipment. And so we had our prototype that was brought to that conference. And then of course, the global pandemic shut everything down. So one of the things that our CEO and our director of applications were planning on doing is once they had this working prototype, they were just going to travel across the US and just do all these samples for all these different labs or industries. And obviously they would have been spreading COVID all around the country. So good thing they didn't do that. So what we've done instead is this virtual demonstration program where when we talk to someone who has an interest or has an application that this could work for, they send samples to our lab, we analyze them and then go through the results with them in a virtual meeting. So yeah, it can be a little bit challenging to sell a new instrument and demonstrate its capabilities in a global pandemic.
Yeah, but I love the fact that you were creative and found a virtual solution. So that's really good. It's really interesting. Well, thank you. So let's go back and address the question to Sunil, and then I have I think there are a couple of questions for Amy. So Sunil, did you want to answer the question about?
Yes, sure. So yeah, I think there was one question about the data, right? So William asked that were we able to convince somebody to share the data, right? And you know, everybody knows that's a difficult problem, basically, that everybody wants to do machine learning, but data becomes a pretty big hurdle. So there are two things that really at least helped us at DataVedik. The first one was when we started the company, first 3 months were all about collecting and amassing data. So we have a huge amount of US and Canada data that we collected ourselves, and also we collected with a small partner. Right? We didn't want to go to a IHS or drilling info kind of situation at that time, simply because we were too small. Okay, we just We just didn't have that kind of money to invest in the data at that time. We ended up doing our own and with a small partner. So that has given us a leg up. So that has been very, very useful for all the research that we did. The second thing that really helped us, that actually came from an operator. They gave us about 200 wells, right, with all the drilling data, including all the sensors data. And then that has been extremely useful because that kind of data sets, generally in US, you will not find that anywhere. In Canada, a few data sets you will find, or you can find it in like open data sets like Valve, where there is very limited amount of data, right? So you cannot really build a solution at scale or test it at scale unless you have, good, reasonable amount of data. So that was very helpful. In general, I would say it is a difficult proposition to convince at least an operator or even an oil field services company to share a good volume of data without, let's say, anonymizing that data or scrambling that data, which hides a lot of things. Just to give you an example, we are doing a SPE as part of SPE Data Analytics Group. We are conducting a hackathon right now. We took a data set from a data service provider. And one of the first objections that came from the people was that the locations were scrambled. I mean, it was part of the conditions under which we got the data. But yeah, it's not an easy problem to solve, but if you have a good enough value proposition, you can make it. That's all I would say.
Great. Well, thank you. So Amy, I have a question for you. So how do you overcome some of these like intellectual property anxieties?
Well, there's a couple things, right? I mean, a part of our alliance, when we put this together, that was a requirement, right? That none of the IP is taken. And that's looking at fundamentally changing the way startups have traditionally been required to sign these massive MSAs that are 70 to 80 pages, right? So, I mean, it's not about working with the companies per se, it's the mindsets of them, right? And so, if there's that requirement that they feel the need to kind of, have access or take, some of the old attitude is, well, I'm helping the startup, right? It ends up being kind of a hybrid approach. That's just not helping extend the runway for that particular startup, right? It becomes a hindrance. And then we also, sign, CAs and NDAs with the startups. And we're very cautious with them, right? So if we feel like, there's going to be a big exposure, if it's very, very risky for them, we'll say, okay, listen, we probably need to hold on going further until you have some sort of IP strategy and protection around your technology, right? So, it's really, really important to kind of, coach them and be mindful of that, right? And then we also tell them, when you talk to VCs, right, you're going to have to just judge the risk because most of the investors are not going to sign that CA and NDA with you. And, you're just going to have to kind of tread that very, very carefully, right? But yeah.
That's good. Well, I was kind of interested in hearing what Sudhir says too, because I mean, when you're talking about, for example, technology from the rover and NASA, you want technology transfer, but then what happens when there's IP anxiety? And so, Sudhir, could you address that?
Yeah, sure. I mean, these are places where one of the ways that the IP anxiety can be taken away is the classic technology transfer, right? You just, which is why I think more and more over a period of time, there's licensing of a technology that kind of belongs to somebody else, but you want to use it. And the whole idea that that particular technology was developed so that it can be shared with others. And one of the ways you can share with others, and it's worked extremely well in a lot of industries, particularly in the energy industry that we've come from, is licensing. And worked extremely successfully, and it's one of the best ways from a business case. Either you license it, understanding that it doesn't matter how much revenue you get, or there is the other world called royalty, wherein you license it, understanding that the people from whom you license make money only if you make money. And this is where the business of royalty comes. You make money and then a part of it goes to them. So 3 or 4 different business models exist, and there is always an option to go for a business model which makes sense. Small, medium type companies, startups, etc., who do not have a lot of capital at hand, the royalty works very well. That is, you pay with the use, and this is why some of these separations have been set up. So certainly my experience has been, provided there is a will to collaborate and to work together, people always figure a way out to find out how they will share technology, and it certainly works. I've seen, put it this way, more success stories than I hate to use the word horror stories. Yeah.
That's great. And
more so in current times, wherein you look at the challenges that we are going through, and look at these challenges as a way to find opportunities, right?
I like that, because we're kind of looking at what off-label kind of uses of the technology or licensing. John, would you like to say a few final words before we wrap up?
Sure, I can do that. I think we've heard a lot of common themes today. We've heard a lot about the resistance to change and the challenges around adopting technologies. And I kind of revert to my point. There's not a one-size-fits-all solution on how to do this. There's not a great answer for, there's not some magical key that unlocks the door to operators, and there's not some magical solution for us, unfortunately, to do the increase the speed of adoption. All we can do is keep trying to do things better. And, I think that's true across the board. And, we really try to work with startups in a positive way where it's a win-win. And I think that's the best way to do it, to keep trying to get better. Because I think there's no doubt in our industry, we have to change, we have to improve the way we operate, the way we do things, and the way we interact with others. So we'll keep doing that.
That's great. So as we finish up, I just want to thank our presenters. I'd like to thank you, Amy, and John, and Sudhir, and Sunil, and Ellen. This is just fantastic, and I really appreciate the flexibility with our new format. So really, I appreciate everybody's participation in the audience as well. I want to thank Rekha Patel also for just talking about Strathus, and I'd like to encourage everybody to check it out. It's free, and it's a collaboration space, and I'd like to encourage you to go ahead, and if you have a technology, put it in the Innovation Hut. I can't remember if we call it Innovation Hut or Technology Hut, but it's a hut. and then finally download the AAPG mobile app, and you'll be getting an email from me in a couple of days with a link to the recording for this, and also a chance to sign up for the next one, which will be in 2 weeks, not 1 week. We'll be on 2-week intervals. It's just this first week. Didn't want to start on the inauguration day. That was the original, so we pushed it a week. So anyway, so I want to thank you. And if there are any questions, just put them in the chat box and contact me and contact the participants. Well, you can get in touch with us directly or through the collaboration cluster. So thank you, everyone.
Just one more final word, Susan. Thank you very much for organizing this and the invitation. Me and I'm sure on behalf of the other panelists. These are always good sessions, and thank you for organizing and facilitating them.
Oh, you're quite welcome. Thank you.
And I second John. He beat me to it in by a couple of seconds. Absolutely. Listen, wonderful way of putting these sessions together. I saw a commonality between the various speakers which came through, and hopefully the audience found it interesting that we came from various angles, but we were talking about similar themes and similar languages. Yeah.
And then now we'll have a chance to put it into action as we collaborate in the future. So I really would like to see people have breakthroughs and have material benefits from participating in these.
Thank you.
Susan.
So thank you.
Thank you. Yeah.
Thank you. Have a
Thank
good
you.
evening.
Thanks, Susan. Thanks, everyone.